You were lied to. Not by conspiracy theorists, not by fringe scientists, by your elementary school teachers, your textbooks, even NASA itself. For decades, you've been fed a sanitized version of the solar system, a neat, orderly diagram with 9 planets, or maybe 8, arranged in perfect circles around a burning yellow sun. But almost every single thing you learned was wrong. The asteroid belt is not a deadly minefield. The sun does not burn. Mercury is not the hottest planet. And here is the worst part. These lies are still being taught right now in classrooms around the world. Today we are exposing 33 of the biggest solar system myths that fooled generations. And by the end of this video you will never look at space the same way again. If you want to know the truth about the universe while everyone else lives in comfortable ignorance, you need to be subscribed to this channel. Now, let us start with the lie that could have killed every space mission ever launched. You think you know our solar system. You have been taught since elementary school about the 9 planets, the burning sun, and the deadly asteroid belt. But here is the unsettling truth. Almost everything you learned was a carefully constructed lie. Not a conspiracy, but something far more disturbing. A web of misconceptions so deeply embedded in our culture that even scientists believed them for centuries. And some of these lies, well, they are still being taught in classrooms right now. Today, we are tearing down 33 of the biggest myths about our cosmic neighbourhood. And what you discover might make you question everything you thought was solid science. Let us start with the most dangerous myth of all, the one that could have killed every space mission we have ever launched. Lie number 1. The asteroid belt is a deadly obstacle course that will destroy spacecraft. You have seen it in Star Wars, in The Empire Strikes Back. Ships weaving desperately through tumbling rocks the size of buildings, explosions everywhere, certain death at every turn. The droid C-3PO warns that the probability of successfully navigating an asteroid field is approximately 3,720 to 1. Hollywood burned this image into our collective consciousness. A dense minefield of death floating between Mars and Jupiter. The reality will shock you. The asteroid belt is almost completely empty. Think about that for a second. When Pioneer 10 became the first spacecraft to enter the asteroid belt in July of 1972, NASA scientists were genuinely concerned. They were not sure if the spacecraft would survive. They had calculated the risks based on what little they knew, and the numbers looked grim. But here is what actually happened. Pioneer 10 sailed through without incident. So did Pioneer 11. Then came Voyager 1 and Voyager 2. Then Galileo, Cassini, New Horizons, and 9 other spacecraft. Not a single one has ever been damaged by an asteroid collision while crossing the belt. Why? Because the average distance between asteroids is 600,000 miles. That is 24 times the circumference of Earth. If you stood on one asteroid and looked around with the naked eye, you probably would not see another asteroid at all. They would be too faint, too far away. The entire asteroid belt contains maybe 1.1 to 1.9 million asteroids, larger than half a mile across. Sounds like a lot, right? But if you gathered every single one of them into a single body, you would end up with a dwarf planet only 930 miles in diameter. The asteroid belt is so sparsely populated that NASA estimates natural collisions between 2 asteroids happen once every 10 million years. And here is the kicker. The chance of a spacecraft randomly hitting an asteroid while passing through the belt is less than 1 in a billion. You're more likely to win the lottery 3 times in a row. This myth did not just come from Hollywood. It came from our fundamental misunderstanding of scale. Space is big, incomprehensibly big, and we keep trying to shrink it down to something our human brains can understand, which leads us directly to lie number 2. Lie number 2. The sun is on fire. Ask a random person on the street what the sun is, and they will probably say it is a giant ball of fire. It is burning. It is consuming fuel. It needs oxygen to keep going. This belief is so ancient it predates written history. The Aztecs thought the sun needed blood sacrifice to keep burning. In the 1800s, scientists calculated that if the sun were burning coal, it would only last a few thousand years. They were right about one thing. The sun is not burning coal. But they were wrong about almost everything else. The sun is not on fire at all. Fire requires oxygen and combustion. The sun has neither. What you're looking at is not a campfire. It is a hydrogen bomb, a continuous thermonuclear explosion held together by its own gravity. Here is how it actually works. At the core of the Sun, temperatures reach 16 million Kelvin. That is not a typo. 16 million degrees. At this temperature and under crushing pressure, equivalent to 260 billion times Earth's atmosphere, hydrogen atoms are squeezed so hard they overcome their natural electromagnetic repulsion and fuse together. 4 hydrogen nuclei combine into one helium nucleus. But here is the critical part. That new helium nucleus has slightly less mass than the 4 hydrogen nuclei that created it. Where did that missing mass go? It became energy. Pure, raw energy. Einstein was right. E equals mc squared. Mass and energy are the same thing. Every single second, the Sun converts 4.26 million metric tons of matter into energy. Not fuel, not ash, just gone. Transformed into the light and heat that makes life on Earth possible. The Sun does not need oxygen. It does not need fuel in the traditional sense. It just needs enough hydrogen and enough gravity to keep the fusion going. And it has plenty of both. 74% of the Sun's mass is still hydrogen. Even though it is losing mass at this staggering rate, the Sun has been doing this for 4.6 billion years, and it has enough fuel left to continue for another 5 billion years. When you understand this, you realize the Sun is not burning. It is exploding, very, very slowly. But most people will go their entire lives believing the Sun is just a big fire in the sky, and that brings us to the third lie, one that fooled even scientists for decades. Lie number 3. Mercury is the hottest planet because it is closest to the Sun. Logic says this should be true. Mercury orbits at only 36 million miles from the Sun. It is absolutely blasted with solar radiation. During the day, the temperature on Mercury reaches 430 degrees Celsius, hot enough to melt lead. Meanwhile, Venus orbits at 67 million miles from the Sun, nearly twice as far. It should be cooler, right? Wrong. Venus is hotter, much hotter. The average temperature on Venus is 464 degrees Celsius. Day and night, equator and poles. Venus never cools down. But here is the truly terrifying part. That temperature is not just at the surface. 30 miles up in the atmosphere, the temperature is still around 70 degrees Celsius. Comfortable enough for humans, ironically, if you could somehow float at that altitude without being dissolved by sulfuric acid clouds. So what happened? Why is Venus hotter than Mercury despite being farther from the Sun? The answer is one word: atmosphere. Mercury has almost no atmosphere, just a thin exosphere of atoms blasted off its surface by solar wind. When the Sun hits Mercury during the day, it heats up fast. But when the Sun sets, which takes a very long time because Mercury rotates so slowly, the temperature plummets to minus 180 degrees Celsius. With no atmosphere to trap heat, it all radiates back into space instantly. Venus, on the other hand, has an atmosphere from hell, literally. The atmospheric pressure at the surface is 90 times that of Earth. Imagine being almost a mile underwater. That is the pressure on Venus, and that atmosphere is 96.5% carbon dioxide, a greenhouse gas. Every bit of solar energy that penetrates the thick clouds gets trapped by this carbon dioxide blanket. The heat cannot escape. It just builds and builds and builds. This is what scientists call a runaway greenhouse effect, and Venus was not always like this. About 4 billion years ago, Venus might have been similar to Earth. It might have had liquid water oceans, but something triggered a feedback loop. The temperature rose slightly. Water began to evaporate. Water vapor is also a greenhouse gas, so the temperature rose more. More water evaporated. Eventually, all the water was gone, broken apart by ultraviolet radiation into hydrogen and oxygen. The hydrogen escaped into space. The oxygen combined with surface rocks. What was left was a planetary scale oven with no way to turn down the heat. Venus is now the hottest planet in the solar system, and it is a warning. A cautionary tale written in the sky about what happens when greenhouse effects spiral out of control. But we're just getting started with the lies. The next one is so widespread that even space agencies got it wrong for years. Lie number 4. There is no gravity in space. You've seen the footage 1,000 times. Astronauts floating gracefully inside the International Space Station, objects drifting through the air, water forming perfect spheres. It looks like gravity has been turned off, so naturally we call it zero gravity. Zero G, weightlessness. Even NASA used these terms for decades, but they were technically lying to you. There is gravity in space, lots of it. In fact, at the altitude where the International Space Station orbits, Earth's gravity is still about 90% as strong as it is on the surface. If you could somehow build a tower tall enough to reach the space station, and you climb to the top, you would still weigh 90 pounds if you normally weigh 100 pounds on the ground. So why do astronauts float? Because they are falling, constantly falling. The International Space Station is falling toward Earth right now, it never stops falling. But it is also moving sideways incredibly fast. 17,500 miles per hour. So fast that as it falls toward Earth, the planet's surface curves away beneath it at exactly the same rate. The station falls around the Earth instead of into it. And here is the key. Everything inside the station is falling at exactly the same rate. The astronauts, the equipment, the air, the walls, they are all in free fall together. When you are in free fall, you do not feel your weight. Not because gravity disappeared, but because there is nothing pushing back against you. On Earth, you feel your weight because the ground pushes up on your feet. In orbit, there is no ground, just constant, endless falling. This is what physicists call microgravity, not zero gravity, microgravity. Because there are still tiny gravitational effects, tidal forces from the slight difference in gravity between one end of the station and the other, gravity from the sun, the moon, other objects, air resistance, though very thin. Even the movements of astronauts themselves create tiny gravitational effects. But for all practical purposes, everything feels weightless. This is not just a semantic distinction. Understanding the difference matters. It explains why astronauts' bodies deteriorate in space. They lose bone density at about 1 to 1.5% per month. Their muscles atrophy because they are not working against gravity anymore. Their cardiovascular systems weaken. Their vision changes because fluids in the body redistribute differently. NASA has to make astronauts exercise 2 hours every single day just to slow down these effects. And even then, when they return to Earth after 6 months, it takes months more to fully recover. The term zero gravity is not just inaccurate, it is misleading. It makes people think space is somehow fundamentally different from Earth, when really, astronauts are just experiencing the same physics we do. Just in a really, really long fall. But if that myth surprised you, wait until you hear the next one. This lie has persisted for thousands of years and still trips people up today. Lie number 5. The sun is yellow. Quick. Picture the sun in your mind. What colour is it? Yellow, right? Maybe orange. That is what we draw as children. That is what appears in every emoji, every icon, every illustration. The sun is yellow. Except it is not. The sun is white. Pure white. Go outside right now on a clear day and look at the sun. Do not actually do that. You will damage your eyes. But if you could safely observe the sun from space, you would see that it emits light across the entire visible spectrum. Red, orange, yellow, green, blue, indigo, violet. All colours combine together in roughly equal amounts. When you combine all visible light wavelengths, you get white, not yellow. The sun is classified as a G-type main sequence star, and yes, it peaks in the yellow-green part of the spectrum. But the overall output is white. So why do we see it as yellow from Earth? Our atmosphere. When sunlight passes through Earth's atmosphere, something called Rayleigh scattering occurs. Shorter wavelengths, blue and violet, scatter more easily than longer wavelengths like red and yellow. This is why the sky is blue, all that scattered blue light bouncing around. But it also means that by the time sunlight reaches your eyes, some of the blue has been filtered out. What remains looks slightly more yellow. The effect is more pronounced when the sun is low on the horizon at sunrise or sunset. The light has to travel through more atmosphere, scattering even more blue light, leaving mostly reds and oranges. But at noon, when the sun is directly overhead and the light path through the atmosphere is shortest, the sun appears much closer to its true colour, white, or perhaps very pale yellow. And here is proof. Look at photographs of the sun taken from space. The International Space Station, the moon landings, any spacecraft outside our atmosphere. The sun is white, always white. Or look at the moon. The moon does not emit its own light. It reflects sunlight. And what colour is the moon? Grey-white. If the sun were truly yellow, the moon would look yellow too. This myth persists because we have been conditioned by culture. Every image we see, every drawing, every representation reinforces the yellow sun. We teach our children to colour the sun yellow. We never question it. But the truth is hovering right above our heads, hidden only by the filter of our own atmosphere. And speaking of the moon, that brings us to the sixth lie, one of the most famous misconceptions in astronomy. Lie number 6. There is a dark side of the moon that never sees sunlight. Pink Floyd made an album about it. Countless science fiction stories have been set there. The mysterious, permanently dark side of the moon, a place of eternal night, hidden from view, unknown and unknowable. It is one of the most romantic myths in all of astronomy, and it is completely wrong. There is no dark side of the moon, not in the way people imagine. The moon does have a far side, a hemisphere that permanently faces away from Earth, but that far side gets just as much sunlight as the near side. The confusion comes from tidal locking. The moon rotates on its axis at exactly the same rate that it orbits Earth. This means the same face always points toward us. We never see the other side. Never. For all of human history, the far side of the moon was hidden from view. That changed in October 1959 when the Soviet spacecraft Luna 3 took the first photographs of the far side. And guess what people saw? No eternal darkness, no mysterious shadow realm. Just more moon, craters, Maria, mountains. Similar to the near side, though with some interesting differences. Here is how it actually works. As the moon orbits Earth over the course of about 29.5 days, sunlight hits different parts of its surface. During a new moon, when the moon is between Earth and the sun, the far side is fully illuminated while the near side is dark. During a full moon, when Earth is between the sun and the moon, the near side is fully illuminated while the far side is dark. Every part of the moon gets roughly 2 weeks of daylight followed by 2 weeks of darkness. There is no permanently dark side, just a far side that we cannot see. And why do people call it the dark side anyway? The term comes from the idea of something hidden, unknown, mysterious. Dark meaning obscure, not dark meaning unlit. But over time, the meaning got confused and people started to literally believe that side of the moon never saw the sun. This myth is so persistent that it has been debunked hundreds of times, and yet it keeps coming back. Maybe because the truth is less interesting. There is no forbidden zone, no eternal night, no dark side. Just a far side, as ordinary as the side we see every night. But at least that myth is harmless. The next lie actually influenced public policy and could still affect space exploration today. Lie number 7. Pluto is not a planet anymore because scientists changed their minds arbitrarily. Let me set the scene. August 24, 2006. Prague. The International Astronomical Union holds a vote. 424 astronomers out of 10,000 worldwide decide the fate of Pluto. The resolution passes. Pluto is no longer the 9th planet. It is now classified as a dwarf planet. The public backlash was immediate and fierce. People felt betrayed. How could scientists just decide that a planet is not a planet anymore? Kids who grew up with 9 planets suddenly had to relearn the solar system with only 8. Textbooks had to be rewritten. Mnemonics like "my very educated mother just served us 9 pizzas" no longer worked, and it seemed so arbitrary. So the common narrative goes like this. Scientists got together, voted, and on a whim, demoted Pluto. It was a power grab. It was tradition versus progress. It was old astronomers being mean to a beloved underdog of a planet. But that narrative is a lie. What really happened was far more complex and far more scientifically justified. The problem was not Pluto. The problem was that we kept discovering objects like Pluto. In the 1990s, astronomers found the Kuiper Belt, a region beyond Neptune filled with thousands of icy bodies. Some of them were big. Some of them were comparable to Pluto in size. In 2005, astronomer Mike Brown discovered Eris, an object slightly more massive than Pluto. If Pluto was a planet, then Eris had to be a planet too. And if Eris was a planet, then dozens, maybe hundreds of other Kuiper Belt objects would qualify as planets. The solar system would suddenly have 50 planets, 100 planets, who knows how many. We needed a definition. Before 2006, the term planet had never been formally defined, it was just understood. You knew a planet when you saw one. But that is not science. Science requires precise definitions, so the IAU created 3 criteria for an object to be called a planet. 1, it must orbit the Sun. 2, it must be massive enough that its own gravity pulls it into a roughly spherical shape. 3, it must have cleared its orbit of other debris. Pluto meets the first 2 criteria, but not the third. Pluto shares its orbital neighbourhood with thousands of other Kuiper Belt objects. It has not gravitationally dominated its region of space. Neptune, by comparison, is about 8,000 times more massive than all the other objects in its orbit combined. That is a cleared orbit. Pluto, on the other hand, is only about 7% of the mass of all the objects in its orbital zone. It has not cleared anything. So Pluto was reclassified as a dwarf planet, along with Ceres, Eris, Makemake, Haumea, and others. This was not arbitrary. This was not a whim. This was scientists trying to create consistent, meaningful categories. Now, not everyone agrees with this decision. Planetary scientist Philip Metzger argues that the clearing the orbit criterion is based on astrological thinking, not science. He points out that most planetary scientists still refer to Pluto as a planet in their research papers, and he is right. The definition has flaws. Jupiter has not cleared its orbit. There are thousands of asteroids sharing its orbital space, the Trojan asteroids, but the IAU definition was an attempt, however imperfect, to bring order to a rapidly expanding understanding of our solar system. The real lie is not that Pluto was demoted. The real lie is that it ever should have been considered a planet in the first place, given what we now know. And that brings us to a related myth that confuses people even more. Lie number 8. Pluto is tiny, barely bigger than our moon. This one requires a bit of nuance because it is technically true, but incredibly misleading. Pluto is indeed smaller than Earth's moon. Pluto's diameter is about 1,477 miles. Earth's moon is about 2,159 miles across. So yes, Pluto is smaller, but calling Pluto tiny misses the point entirely. Pluto is not tiny for what it is. Pluto is the largest known dwarf planet by diameter in the Kuiper Belt, at least until we get better measurements of some newly discovered objects. It has 5 known moons. Its largest moon, Charon, is so big relative to Pluto that the 2 bodies actually orbit a common centre of mass that lies outside Pluto itself. They are essentially a binary system, 2 objects dancing around each other. Pluto has a thin atmosphere of nitrogen, methane, and carbon monoxide. When Pluto is closest to the Sun, this atmosphere expands. When it moves farther away, the atmosphere freezes and falls to the surface as snow. Pluto has weather. It has seasons that last decades. In 2015, NASA's New Horizons spacecraft flew past Pluto and sent back the most stunning images anyone had ever seen. Pluto was not some dead, boring ice ball. It was geologically active. It had towering mountains made of water ice as hard as a rock. It had vast plains of frozen nitrogen, with patterns that suggested convection, material churning and flowing like a lava lamp. It had a giant heart-shaped region on its surface that immediately captured public imagination. Scientists found evidence of cryovolcanoes, ice volcanoes that spew water, ammonia, and methane instead of lava. Pluto had complex chemistry, intricate geology, and an active past that was completely unexpected. Calling Pluto tiny ignores all of this. It reduces a fascinating, complex world to a number, a size comparison that does not do justice to what Pluto actually is. And that comparison to Earth's moon, that is misleading too. Our moon is unusually large for a moon. Most moons in the solar system are much smaller relative to their parent planets. Earth's moon is so large relative to Earth that some scientists argue we should call the Earth-Moon system a double planet. Pluto is not tiny. It is a vibrant, active world, just smaller than the rocky planets we're familiar with. And speaking of things being smaller than we think, here is another myth about scale. Lie number 9. The Sun is huge compared to the planets. The Sun is massive. About 333,000 times the mass of Earth. It contains 99.86% of all the mass in the solar system. Everything else, all the planets, moons, asteroids, comets, dust, everything, is only 0.14%. So yes, the Sun is huge. But here is what people do not realize. The Sun is also a star. and as stars go, it is actually quite small. Our Sun is classified as a yellow dwarf, not a giant, not a supergiant, a dwarf. There are stars out there that make the Sun look like a grain of sand on a beach. Take Betelgeuse, the red supergiant star in the constellation Orion. If you replace the Sun with Betelgeuse, its surface would extend past the orbit of Mars. It would swallow Mercury, Venus, Earth, and Mars whole. Or consider UY Scuti, one of the largest known stars. Its radius is about 1,700 times that of the Sun. If you placed UY Scuti where the Sun is now, it would engulf everything out to the orbit of Saturn. The Sun, by comparison, is tiny. But there is another twist. The Sun is actually larger than most stars in the universe. About 75% of stars are red dwarfs, smaller and cooler than the Sun. Some of these red dwarfs are only about 10% the size of the Sun. So the Sun is both small compared to giants and supergiants, and large compared to the majority of stars. This leads to a fundamental misunderstanding of scale. When we talk about the solar system, we imagine the Sun as this dominant, overwhelming presence. And it is, gravitationally. But in terms of sheer size, compared to the largest stars, the Sun is modest. And when you zoom out further, to the scale of galaxies, the Sun becomes invisibly small. A single point of light among hundreds of billions of stars in the Milky Way alone. One galaxy among trillions in the observable universe. The Sun is huge compared to Earth. But it is humblingly small compared to the cosmos, and that brings us to another myth about the Sun that almost no one gets right. Lie number 10. The Sun will explode when it dies. Movies love this idea. The Sun growing brighter and brighter, then suddenly exploding in a catastrophic supernova that obliterates the solar system. It is dramatic. It is terrifying. It is also completely impossible. The Sun does not have enough mass to go supernova, not even close. For a star to explode in a supernova, it needs to be at least 8 to 10 times the mass of the Sun. Our Sun is simply too small. So what will happen instead? In about 5 billion years, the Sun will start running out of hydrogen fuel in its core. When that happens, it will not explode. It will expand. The core will contract, heating up, while the outer layers expand outward. The Sun will become a red giant. It will grow so large that its outer layers will likely reach Earth's orbit. Mercury and Venus will definitely be consumed. Earth might be too, depending on exactly how much mass the Sun loses during this process. But even if Earth survives being swallowed, it will be a scorched, lifeless rock. The oceans will boil away. The atmosphere will be stripped. Nothing will survive. Then, over millions of years, the Sun will shed its outer layers in a series of pulses, creating a beautiful planetary nebula, a glowing shell of gas and dust expanding into space. What will be left behind is the Sun's core, compressed into an object about the size of Earth, but with the mass of the Sun. This is called a white dwarf. The white dwarf will slowly cool over billions of years, eventually becoming a black dwarf, a cold, dark, dead remnant. No explosion, no supernova, just a slow, inevitable decline. The Sun's death will be dramatic in its own way, but it will not be explosive. It will be more like a gentle sigh, a long goodbye spread over millions of years. This myth probably persists because we hear so much about supernovae in popular science. They are exciting, violent, spectacular. But supernovae are rare. Most stars, including the Sun, die much more quietly. And that quiet death, strangely, is just as terrifying, because it is inevitable, inescapable, already written into the physics of the universe. 5 billion years is a long time. Humanity might not even exist by then, but the Sun's fate is sealed. It will not explode. It will just fade away. Now let us talk about something closer to home. A myth about the Earth itself that causes confusion every single year. Lie number 11. Summer is hotter because Earth is closer to the Sun. This seems so logical. In summer, it is hot. In winter, it is cold. Earth must be closer to the Sun in summer and farther away in winter, right? Wrong. Earth's orbit is slightly elliptical, not a perfect circle, but the difference is tiny. Earth is closest to the Sun in early January during winter in the Northern Hemisphere. It is farthest from the Sun in early July, during summer in the Northern Hemisphere. The opposite of what most people think. So if distance does not cause seasons, what does? The tilt of Earth's axis. Earth is tilted at about 23.5 degrees relative to its orbit around the Sun. This means that as Earth orbits the Sun, different parts of the planet receive more direct sunlight at different times of year. In June, the northern hemisphere is tilted toward the Sun. Sunlight hits at a more direct angle, concentrating energy over a smaller area. Days are longer, nights are shorter. This is summer. In December, the northern hemisphere is tilted away from the Sun. Sunlight hits at a shallow angle, spreading the same amount of energy over a larger area. Days are shorter, nights are longer. This is winter. The southern hemisphere experiences the opposite pattern. When it is summer in the north, it is winter in the south. And vice versa. Distance from the Sun has almost nothing to do with it. This myth is so pervasive that it shows up in educational materials, textbooks, even some science classes. Teachers inadvertently reinforce it because it makes intuitive sense. But intuition is wrong. Here. The tilt of the axis is everything, and here is the kicker. Earth's elliptical orbit does affect climate slightly, but the effect is counterintuitive. When Earth is closer to the Sun in January, the northern hemisphere is in winter. The extra solar energy helps moderate the winter cold slightly. When Earth is farther from the Sun in July, the northern hemisphere is in summer. The reduced solar energy helps moderate the summer heat slightly. The effect is tiny, but it is the opposite of what people expect. This misunderstanding matters because it affects how people think about climate change. If people believe seasons are caused by distance from the Sun, they might mistakenly think that small changes in Earth's orbit could explain global warming. They cannot. Climate change is driven by greenhouse gases, not orbital variations. Now let us move to another common myth about how the solar system formed. Lie number 12. The planets formed in a neat, orderly line from the Sun. Look at any diagram of the solar system. Mercury, Venus, Earth, Mars, then the asteroid belt, then Jupiter, Saturn, Uranus, Neptune. All neatly spaced like beads on a string. This gives the impression that the solar system formed in a simple, orderly way. Small rocky planets close to the Sun, gas giants farther out, ice giants even farther. It all seems very organized. The truth is far more chaotic. The solar system did not form in a line. It formed from a rotating disk of gas and dust called the solar nebula. About 4.6 billion years ago, this nebula began to collapse under its own gravity. Most of the mass fell toward the center and became the Sun. The remaining material spread out into a flat disk. Within this disk, particles began to stick together through static electricity and gravity. Dust grains clumped into pebbles, pebbles into boulders, boulders into planetesimals, objects the size of mountains, planetesimals into protoplanets, objects the size of moons. And eventually protoplanets collided and merged into full planets. But this process was violent and unpredictable. Planets migrated. They moved inward and outward through the disk, pulled by gravitational interactions with the gas and with each other. Jupiter, for example, probably formed much farther out than where it is now. It migrated inward, possibly as close as where Mars is today, before migrating back outward again. This migration scattered smaller objects everywhere. It disrupted the formation of planets in the inner solar system, which is why Mars is so much smaller than Earth and Venus. It flung asteroids and comets into the inner solar system, causing a period called the Late Heavy Bombardment, about 4 billion years ago, when the inner planets were pummeled by impacts. Some planets probably formed in completely different locations than where they are now. Uranus and Neptune might have swapped places. There might have been additional planets that were ejected from the solar system, entirely, flung into interstellar space by close encounters with Jupiter. The current arrangement of planets is not the result of orderly formation. It is the result of billions of years of gravitational chaos slowly settling into a relatively stable configuration. And here is the scary part. It is not done. The solar system is still evolving. Orbits are still changing, just very, very slowly. In a few billion years, the arrangement of planets might look completely different. Mercury might be ejected. Venus and Earth might collide. Or maybe nothing dramatic will happen, and the system will stay mostly the same. We cannot predict it with certainty because the math of multiple gravitational bodies is chaotic. Tiny changes now can lead to massive differences later. The neat diagram in your textbook is a lie. The solar system is messy, chaotic, and always changing. But at least that chaos happened billions of years ago, right? Not quite. Our next lie is about something happening right now. Lie number 13. The asteroid belt is the remains of a destroyed planet. For a long time, astronomers believed the asteroid belt was the debris of a planet that somehow exploded or broke apart. The gaps in the solar system seemed to suggest a missing planet between Mars and Jupiter, and the asteroids were conveniently located right where that planet should have been. It seemed like a tidy explanation, a tragedy written in stone and ice. But it is not true. The asteroid belt is not the remains of a destroyed planet. It is the remains of a planet that never formed in the first place. Here is what really happened. When the solar system was forming, the region between Mars and Jupiter should have produced a planet. There was plenty of material there, but Jupiter's gravity was too strong. Jupiter is so massive, 318 times the mass of Earth, that its gravitational influence disrupted the formation process. Every time planetesimals started to clump together in that region, Jupiter's gravity would perturb their orbits, causing them to collide at such high speeds that they shattered instead of merging. Over time, most of the material in that region was either ejected from the solar system entirely or swept up by Jupiter and the other planets. What we see today as the asteroid belt is only a tiny fraction of the original material. If you combined every asteroid in the belt into a single body, it would form a dwarf planet about the size of Pluto, far smaller than even Mercury. The asteroid belt is not a destroyed planet. It is a failed planet. A planet that never got the chance to exist because Jupiter's gravity said no. And this has implications beyond just understanding the past. The asteroid belt gives us a window into the early solar system. Asteroids are primitive objects, largely unchanged since the solar system formed. Studying them tells us what the raw materials of planets looked like 4.6 billion years ago. Some asteroids contain water ice. Some contain organic compounds, the building blocks of life. Asteroids might have been responsible for delivering water and organic molecules to Earth in the early days, seeding our planet with the ingredients needed for life. So the asteroid belt is not a graveyard, it is a time capsule. But enough about rocks in space. Let us talk about ice, specifically the myth about comets that has caused unnecessary panic for centuries. Lie number 14. Comets are harbingers of doom that bring disease and disaster. For most of human history, comets were feared. When a bright comet appeared in the sky, people believed it signaled war, famine, plague, or the death of kings. Ancient texts are filled with records of comets followed by disaster. The appearance of Halley's Comet in 1066, just before the Norman conquest of England, was seen as an omen. Comets were unpredictable, mysterious, terrifying. Even as recently as the 1990s, some people believed comets could cause catastrophes. When Comet Hale-Bopp appeared in 1997, doomsday cults predicted the end of the world. The Heaven's Gate cult believed a spaceship was hiding behind the comet and convinced 39 members to commit mass suicide to reach it. Comets still inspire fear, even in the age of science, but here is the truth. Comets are harmless. Mostly. A comet is just a ball of ice, dust and rock. A dirty snowball, as astronomer Fred Whipple called them. Comets spend most of their time in the frigid outer regions of the solar system, the Kuiper belt or the even more distant Oort cloud. Occasionally, gravitational perturbations send a comet plunging toward the inner solar system. As the comet approaches the Sun, solar radiation heats the ice, causing it to sublimate, turning directly from solid to gas without becoming liquid. This gas, along with dust particles, forms a glowing cloud around the nucleus called the coma. Solar wind and radiation pressure push the coma outward, creating the comet's tail. And here is the key. The tail always points away from the Sun, no matter which direction the comet is moving. This is because the tail is being blown by solar wind, not trailing behind like smoke from a car. Now, are comets dangerous? In theory, yes. If a large comet on a collision course with Earth, the impact would be catastrophic. But this has nothing to do with the comet being a comet. It is just a matter of kinetic energy. Any object of that size and speed, asteroid or comet, would cause devastation. But the idea that comets bring disease or bad luck? Nonsense. Comets do not emit magical doom rays. They do not poison the atmosphere, despite wild claims during the 1910 appearance of Halley's Comet. When some people believed Earth would pass through the comet's tail and everyone would die. In reality, comet tails are so thin that they are essentially vacuum. If Earth passed through one, we would not even notice. Comets are beautiful, scientifically valuable objects. They are messengers from the outer solar system, carrying pristine material from the birth of the planets. Studying comets tells us about the conditions in the early solar system, the composition of the outer planets, and possibly even the origins of Earth's water. But they are not omens, they are not harbingers of doom. They are just ice balls in space, briefly lit up by the sun before returning to the cold darkness from which they came. And speaking of darkness, there is a persistent myth about one of the most famous features of the sun, lie number 15. Sunspots are holes in the sun where you can see the cold, dark interior. For centuries, people believed sunspots were literally holes in the surface of the sun, gaps where you could peer into the cooler interior. It seemed logical. The sun is bright and hot. Sunspots are dark and cooler. Therefore, sunspots must be revealing something beneath the surface, right? Wrong. Sunspots are not holes. They are regions of the sun's surface that are cooler than the surrounding area, but they are still part of the surface. Sunspots appear dark because of their relative temperature. The surrounding photosphere, the visible surface of the sun, is about 5,700 degrees Celsius. Sunspots are about 3,700 degrees Celsius. Still hot enough to vaporize any known material instantly, but cooler than the surrounding area. And because they are cooler, they emit less light, making them appear dark by comparison. But why are sunspots cooler? Because of magnetism. The sun is not solid. It is a ball of plasma, ionized gas, and it has a powerful magnetic field generated by the motion of this plasma. In some regions, the magnetic field becomes incredibly strong, thousands of times stronger than Earth's magnetic field. This strong magnetic field inhibits convection, the process by which hot plasma rises to the surface, cools, and sinks back down. Convection is what brings heat from the sun's interior to the surface. Where the magnetic field is strong, convection is blocked. Heat cannot rise as efficiently. The surface in that region cools down, not a lot, but enough to create a visible dark spot. Sunspots come and go on an 11-year cycle, tied to the sun's magnetic activity. During solar maximum, there are many sunspots. During solar minimum, there are few. Sometimes sunspots can be enormous. The largest sunspots can be wider than Jupiter, and sunspots are often associated with solar flares and coronal mass ejections, massive eruptions of energy and particles that can disrupt satellites, power grids, and communications on Earth. But sunspots themselves are not holes. They are windows into the sun's magnetic activity. They tell us how the sun's magnetic field is evolving, which helps us predict space weather. And understanding space weather is critical for our technology-dependent civilization. A major solar storm could knock out electrical grids, disable satellites, disrupt GPS, and cause trillions of dollars in damage. Sunspots are not mysterious holes. They are warning signs of the sun's fury. And speaking of magnetic fields, here is another myth about Earth's shield against that fury. Lie number 16. Earth's magnetic field is static and unchanging. If you have ever used a compass, you know it always points north. Magnetic north. It has done this for as long as compasses have existed. So it is natural to assume Earth's magnetic field is stable, a permanent feature of our planet. But that assumption is dangerously wrong. Earth's magnetic field is constantly changing. It shifts, it weakens, and sometimes it flips completely. Earth's magnetic field is generated by the motion of molten iron and nickel in the planet's outer core. This motion, driven by heat from the inner core, creates electric currents, which in turn generate a magnetic field. This process is called the geodynamo. But the outer core is a chaotic, turbulent place. The motion of the molten metal is constantly changing, and so is the magnetic field it produces. Over the past century, the magnetic North Pole has been moving. Fast. In the early 1900s, it was in northern Canada. Today, it is in the Arctic Ocean, heading towards Siberia. It is moving about 34 miles per year, and the pace is accelerating. But that is not even the most dramatic change. Earth's magnetic field has flipped many times in the past. North becomes south. South becomes north. The last flip happened about 780,000 years ago. And it will happen again. We do not know when. Scientists are closely monitoring the magnetic field because it has been weakening over the past few centuries. Some researchers believe we might be entering a period of magnetic reversal, or maybe not. The field might strengthen again. We do not have enough data to be sure. What would happen during a magnetic reversal? The magnetic field would not disappear entirely, but it would weaken significantly. It might become more complex, with multiple north and south poles temporarily appearing in odd places. This would leave Earth more exposed to solar wind and cosmic rays. Satellite electronics would be at greater risk. Astronauts in space would receive higher doses of radiation. Power grids might experience more disruptions. And some animals that navigate using the magnetic field, like migratory birds and sea turtles, might become disoriented. But Earth would not be left defenseless. The atmosphere would still block most harmful radiation. Life would survive, as it has survived many past reversals. The idea that Earth's magnetic field is static is comforting, but wrong. Our planet's magnetic shield is dynamic, unstable, and subject to change, and we are living through one of those changes right now. But enough about Earth. Let us talk about Mars and the biggest lie ever told about the red planet. Lie number 17. Mars has, or had, canals built by an ancient civilization. In the late 1800s, astronomer Giovanni Schiaparelli observed Mars through a telescope and reported seeing long straight lines crisscrossing the surface. He called them canali, Italian for channels. But when translated into English, canali became canals, implying artificial construction. And that single mistranslation sparked one of the most enduring myths in history. American astronomer Percival Lowell became obsessed with the idea of Martian canals. He built an observatory in Flagstaff, Arizona, specifically to study Mars. He spent years mapping the canals, drawing intricate diagrams and writing books about the advanced Martian civilization that must have built them. Lowell believed Mars was a dying world, drying out, and the canals were a desperate attempt by Martians to transport water from the polar ice caps to the equator. The public loved this idea. Mars became the home of an alien civilization in decline. Science fiction writers ran with it. H.G. Wells' War of the Worlds depicted Martians invading Earth because their own world was dying. But the canals were never real. They were an optical illusion. Human eyes and brains are wired to see patterns even when none exist. When you look at a distant, blurry image, your brain tries to make sense of it by connecting random features into lines and shapes. This is called pareidolia, the same phenomenon that makes people see faces in clouds or on toast. When astronomers used better telescopes, the canals vanished. When spacecraft finally visited Mars in the 1960s and 70s, they found no canals. Just craters, volcanoes, canyons, and dry riverbeds. Mars did have flowing water billions of years ago, but not in straight artificial canals. The myth of Martian canals persisted for decades, even after being debunked because people wanted to believe. The idea of an ancient Martian civilization was romantic, exciting, hopeful. It meant we were not alone. But wanting something to be true does not make it true. Mars is a barren desert. No canals, no cities, no Martians, at least none that we have found yet. And that leads us to another Mars myth, one that is much more recent but just as misleading. Lie number 18. Mars once had a thick atmosphere just like Earth. When we talk about Mars in the past, we often describe it as a world with oceans, rivers, rain, and a thick atmosphere. A place that might have been habitable. And there is some truth to this. Mars did have liquid water on its surface billions of years ago. We can see the evidence in dried-up riverbeds, lake beds, and minerals that only form in the presence of water. But here is the catch. Mars's atmosphere was never as thick as Earth's. Not even close. Even at its densest, Mars's atmosphere was probably only about 1/3 as thick as Earth's. Enough to support liquid water, but not enough to be Earth-like, and it did not last long. Mars is smaller than Earth, with only about 1/3 the mass. This means its gravity is weaker. Over time, solar winds stripped away most of Mars's atmosphere. Without a strong magnetic field to protect it, the solar wind just blew the atmosphere into space. By about 3.5 billion years ago, most of the atmosphere was gone. The surface pressure dropped. Water could no longer exist as a liquid. It either froze or evaporated. Today, Mars's atmosphere is about 1% as thick as Earth's. It is mostly carbon dioxide with almost no oxygen. You could not breathe it. And the surface pressure is so low that if you stepped outside without a spacesuit, your blood would boil at body temperature. Not because it is hot, but because the low pressure allows water to boil at much lower temperatures. The idea that Mars once had an Earth-like atmosphere is a romanticized version of history. Yes, Mars was warmer and wetter. Yes, it might have been habitable. But it was never a twin of Earth. It was always colder, drier, harsher. And understanding this matters because it affects our plans for Mars colonization. If we want to terraform Mars to make it habitable, we would need to somehow restore a thick atmosphere. But where would that atmosphere come from? Mars does not have enough gas reserves to rebuild what it lost. We would need to import it from somewhere, perhaps from comets, or manufacture it somehow. Terraforming Mars is not impossible, but it is far more difficult than science fiction makes it seem. The myth of Mars's thick atmosphere gives people false hope about how easy it would be to turn Mars into a second Earth. And now, let us jump to the outer solar system and address a myth about the most iconic planet of all. Lie number 19. Saturn is the only planet with rings. Ask anyone to picture Saturn, and they immediately imagine the rings. Bright, beautiful, spectacular. Saturn's rings are so iconic that they define the planet. And for a long time, Saturn was the only known planet with rings. Galileo first observed them in 1610, though his telescope was not powerful enough to resolve them clearly, and he thought they were two moons on either side of Saturn. It was not until 1655 that Christian Huygens correctly identified them as rings. For over 300 years, Saturn's rings were unique. But then, in 1977, astronomers discovered rings around Uranus. In 1979, Voyager 1 discovered rings around Jupiter. In 1989, Voyager 2 discovered rings around Neptune. All 4 giant planets have ring systems. Saturn's rings are just the biggest and brightest. Jupiter's rings are faint and made mostly of dust. Uranus has 13 distinct rings, dark and narrow. Neptune has 5 rings, also faint. So why are Saturn's rings so much more prominent? We do not know for sure. Saturn's rings are made mostly of water ice, which reflects sunlight very well. Other planets' rings are made of darker material. Saturn's rings might also be younger. Some scientists believe they formed relatively recently, perhaps only a few 100 million years ago, when a moon or comet broke apart near Saturn. Over time, the rings will spread out and darken, and eventually they might disappear. But here is the kicker: rings are not unique to planets. Some asteroids have rings. Chariklo, an asteroid between Saturn and Uranus, has 2 narrow rings. So does Chiron, another asteroid. And some exoplanets, planets orbiting other stars, might have ring systems far larger than Saturn's. In 2012, astronomers discovered an exoplanet called J1407b, with a ring system 200 times larger than Saturn's. So enormous that if it replaced Saturn in our sky, the rings would be bigger than the full moon. Saturn is not the only planet with rings, it is just the one with the most impressive rings, for now. And while we are talking about Saturn, let us address another myth about the gas giants. Lie number 20. Jupiter and Saturn are gas giants with no solid surface. The term gas giant gives the impression that Jupiter and Saturn are just big balls of gas floating in space. Clouds all the way down, no surface, nowhere to land, just an endless atmosphere. This is half true and half misleading. Jupiter and Saturn are indeed mostly gas. Hydrogen and helium make up the vast majority of their mass. If you could somehow fly a spacecraft into Jupiter, you would descend through layers of clouds. Ammonia clouds at the top, then ammonium hydrosulfide clouds, then water clouds deeper down. The temperature and pressure would increase as you descended. There is no sharp boundary, no surface where gas ends and solid begins. The gas just gets denser and denser, gradually transitioning from gas to liquid. Eventually, the pressure becomes so intense that hydrogen is compressed into a liquid metallic state, a phase where hydrogen behaves like a liquid metal, conducting electricity. This is what generates Jupiter's powerful magnetic field. At the very center of Jupiter, there is probably a core, not gas, solid, made of rock and ice. This core is estimated to be about 10 to 20 times the mass of Earth, but we are not certain. Measuring the core directly is impossible with current technology. NASA's Juno mission, which has been orbiting Jupiter since 2016, has provided data suggesting the core might be larger and less dense than previously thought. It might even be diffuse, partially dissolved into the surrounding metallic hydrogen. Saturn is similar, layers of gas, liquid, and possibly a solid core. But again, there is no clear surface. If you tried to land on Jupiter or Saturn, you would just sink deeper and deeper until the heat and pressure crushed you. There is no place to stand. So in that sense, calling them gas giants is accurate. But calling them only gas giants ignores the exotic physics happening inside them. Liquid metallic, hydrogen, compressed to densities greater than lead. Cores that might be as large as Earth but under pressures millions of times greater than Earth's atmosphere. These planets are not just gas. They are layers of matter in states that do not exist anywhere on Earth. And that brings us to the next myth, about the planet that barely qualifies as a planet at all. Lie number 21. Uranus is pronounced Uranus and is a joke planet. Let us get this out of the way. Uranus is pronounced Uranus, or Uranus, not Uranus. The name comes from Uranos, the Greek god of the sky. The Latinized version is Uranus. English speakers have struggled with the pronunciation for centuries, and comedians have had a field day with it. But the jokes obscure the fact that Uranus is one of the most bizarre planets in the solar system. First, Uranus is tilted on its side. Its axis of rotation is tilted 98 degrees, meaning the planet essentially rolls around the sun like a barrel. No one is sure why. The most likely explanation is that Uranus was struck by a massive object early in the solar system's history, knocking it onto its side. But that's just a hypothesis. This extreme tilt means Uranus has the most extreme seasons in the solar system. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness. Imagine living on Uranus. Half your life would be an endless day. The other half, an endless night. Second, Uranus is an ice giant, not a gas giant. Yes, it has hydrogen and helium in its atmosphere, but the bulk of the planet is made of water, ammonia, and methane ices. These ices are not frozen solid like ice on Earth. They are hot, compressed, and in exotic phases. Superinic ice, for example, where oxygen atoms are locked in a crystal lattice while hydrogen atoms flow freely like a liquid. This gives the ice some properties of a solid and some of a liquid at the same time. Third, Uranus has a magnetic field, but it is weird. The magnetic field is tilted 59 degrees from the axis of rotation and offset from the planet's centre. This creates a lopsided, tumbling magnetic field that is unlike anything else in the solar system. And finally, Uranus is cold. Really cold. With an average temperature of minus 224 degrees Celsius, Uranus is the coldest planet in the solar system, even colder than Neptune, which is farther from the Sun. Why? We do not know. Uranus radiates almost no internal heat. Most planets emit heat left over from their formation, but Uranus does not. Something happened to Uranus, either during its formation or during that massive impact that tilted it, that caused it to lose or lock away its internal heat. Uranus is not a joke, it is a mystery, and it is time we stopped giggling at its name and started appreciating just how strange it is. And speaking of strange, let us talk about the outermost planet. Lie number 22. Neptune was predicted, through pure mathematics, a triumph of Newton's laws. Neptune's discovery is often presented as one of the greatest successes of theoretical physics. In the early 1800s, astronomers noticed that Uranus was not orbiting exactly where it should. Its path was slightly off. Something was pulling on it. French mathematician Urbain Le Verrier calculated where an unknown planet would need to be to cause these irregularities. He sent his calculations to astronomer Johann Galle, who pointed his telescope at the predicted location. And there it was, Neptune, discovered through the power of mathematics. Except that is not quite what happened. Le Verrier's calculations were based on assumptions that turned out to be wrong. He assumed the unknown planet was at a certain distance from the Sun, following a certain orbit. His math predicted a location. And yes, Neptune was found near that location. But later analysis showed that Le Verrier's predictions were only accurate by luck. If astronomers had searched for Neptune a few years earlier or later, his calculations would have been way off. The real reason Neptune was found is that Gala searched the area immediately and was aided by the fact that Neptune happened to be near its predicted position at that exact moment. If Gala had waited, or if Neptune's orbit had been slightly different, the search might have failed. And here is another wrinkle. British mathematician John Couch Adams independently calculated Neptune's position around the same time as Leverrier. But Adams's results were ignored by British astronomers, partly because of academic politics. So the discovery of Neptune is often credited to Leverrier, even though Adams did the same work. This is not to diminish the achievement. Predicting the existence of an unseen planet based on gravitational perturbations was brilliant. But the story has been mythologized into a tale of perfect mathematical prediction, when in reality it was a combination of good math, luck, and quick observation. Science is often messier than the textbooks let on, and Neptune itself is full of surprises that defy easy explanation. Line number 23. The solar system ends at Neptune. For most of the 20th century, Neptune was considered the edge of the solar system. Beyond Neptune there was nothing, just empty space, the end. But in the 1990s, astronomers discovered the Kuiper Belt, a vast region beyond Neptune filled with thousands of icy objects. Pluto, we now know, is just one of many Kuiper Belt objects. The Kuiper Belt extends from about 30 astronomical units from the Sun, just beyond Neptune, to about 50 astronomical units. And beyond the Kuiper Belt lies the scattered disk, a region of icy bodies on highly elliptical orbits, and beyond that the Oort cloud, a spherical shell of comets that extends perhaps halfway to the nearest star. The Oort cloud is so distant that objects there take millions of years to orbit the Sun. The solar system does not end at Neptune. It extends far beyond, into regions we have barely begun to explore. NASA's New Horizons spacecraft, after flying past Pluto in 2015, continued into the Kuiper Belt and flew past an object called Arrokoth in 2019. Arrokoth is one of the most pristine objects we have ever studied. A contact binary, two objects gently merged together, unchanged since the solar system's formation. We're only beginning to understand how vast the solar system truly is, and there might be more planets out there. In 2016, astronomers Konstantin Batygin and Mike Brown published evidence suggesting the existence of Planet 9, a hypothetical planet 5 to 10 times the mass of Earth, orbiting in the outer reaches of the solar system. Its gravity, they argue, explains the unusual orbits of several distant Kuiper Belt objects. Planet 9 has not been found yet. If it exists, it is faint, distant, and moving slowly. Finding it will take years, maybe decades. But if it does exist, it would rewrite our understanding of the solar system's architecture. The solar system is not a neat, orderly system ending at Neptune. It is vast, complex, and still full of undiscovered secrets. And that brings us to one of the most comforting myths we tell ourselves, lie number 24. The solar system is stable, and will remain this way forever. When you look at the solar system, it seems eternal. The planets orbit the Sun in their predictable paths. Year after year, century after century, millennium after millennium. The same order, the same rhythm. It gives the impression of permanence. But that is an illusion. The solar system is not stable, not in the long term. The problem is a mathematical one called the n-body problem. If you have two objects, like the Earth and the Sun, you can calculate their orbits precisely. Isaac Newton solved this problem in the 1600s. But if you add a third object, the math becomes much harder. And if you add 8 planets, dozens of moons, thousands of asteroids, and countless other objects, the math becomes chaotic. Chaotic in the technical sense. Tiny differences in initial conditions lead to wildly different outcomes over time. We cannot predict the positions of the planets millions of years into the future with certainty. The best we can do is run simulations and look at probabilities, and those simulations are disturbing. In some scenarios, Mercury's orbit becomes so eccentric that it crosses Venus's path. The two planets might collide, or Mercury might be ejected from the solar system entirely. In other scenarios, the orbits of the planets remain stable for billions of years, until the Sun becomes a red giant and engulfs the inner planets. We do not know which scenario will happen because the math is chaotic. Small uncertainties now become large uncertainties over billions of years. And it gets worse. Our solar system exists in a galaxy with hundreds of billions of stars. Occasionally, a rogue star might pass close to the solar system, gravitationally disrupting the orbits of the outer planets or the Oort cloud. This has probably happened many times in the past. It will happen again in the future. The solar system is not a clockwork machine ticking along forever. It is a dynamically evolving system, shaped by chaos and chance. The apparent stability we see is temporary, a snapshot of a system that is always changing, just too slowly for us to notice in a human lifetime. And speaking of change, let us talk about an object that changes more than any other. Lie number 25. Comets only have one tail. When you picture a comet, you probably see a bright head with a single glowing tail streaming behind it. That is how comets are usually drawn. One tail. Simple, beautiful. But real comets often have two tails, one made of dust, one made of gas, and they point in different directions. The dust tail is the one most people think of. It is made of tiny particles, dust and ice, blown off the comet by solar radiation. The dust particles are heavier, so they lag slightly behind the comet, creating a curved tail that follows the comet's orbit. The gas tail, also called the ion tail, is different. It is made of ionized gas, atoms that have been stripped of electrons by ultraviolet light from the sun. This gas is much lighter than dust, and it is blown directly away from the sun by the solar wind. The gas tail always points straight away from the sun, no matter which direction the comet is moving. When a comet is approaching the sun, the gas tail points ahead of the comet. When the comet is moving away from the sun, the gas tail points behind it. But the dust tail is always slightly curved, lagging behind. Some comets have both tails clearly visible, some have only one, some have neither. It depends on the composition of the comet and its distance from the sun. And here is something even more surprising. Some comets develop anti-tails, a spike of dust that appears to point toward the sun. This is not really a tail pointing the wrong way. It is an optical illusion caused by the geometry of the comet's orbit and our viewing angle. Comet tails are far more complex than a single glowing streak. They are shaped by solar wind, radiation pressure, magnetic fields, and the comet's own rotation. Understanding how comet tails work helps scientists learn about the solar wind and the composition of comets themselves. But it also reminds us that nature is more intricate than the simplified pictures we draw. And speaking of simplified pictures, there is a huge myth about the shape of planetary orbits. Lie number 26. Planetary orbits are perfect circles. For thousands of years, humans believed the heavens were perfect. Circles were the most perfect shape. So naturally, the planets must orbit in perfect circles. This idea was codified by ancient Greek philosophers and reinforced by the Catholic Church. Any deviation from perfect circles was considered heretical. But Johannes Kepler, in the early 1600s, realized the orbits were not circles. They were ellipses, slightly squashed circles. Kepler's first law of planetary motion states that planets orbit the Sun in elliptical paths, with the Sun at one focus of the ellipse. This was a revolutionary idea at the time. It broke the perfect circle dogma and paved the way for Newton's laws of gravity. But here is the catch. Most planetary orbits in our solar system are almost circular. Earth's orbit, for example, has an eccentricity of 0.0167. That is very close to a perfect circle. If you drew Earth's orbit to scale, you probably could not tell it was an ellipse just by looking at it. The same is true for most planets. Venus has the most circular orbit, with an eccentricity of only 0.0068. Even Jupiter and Saturn have nearly circular orbits. The only planets with noticeably elliptical orbits are Mercury and Mars, and even those are only slightly elliptical compared to some comets and asteroids. Pluto's orbit is fairly elliptical, with an eccentricity of 0.249, but Pluto is not a planet anymore. So while it is technically true that orbits are ellipses, in practice planetary orbits are so close to circular that the distinction barely matters for most purposes. The myth that orbits are perfect circles is not far from the truth, but clinging to perfect circles for philosophical reasons held back science for centuries. And that is the lesson. Even beautiful, elegant ideas can be wrong. Now, speaking of wrong, let us talk about one of the most repeated myths about the moon. Lie number 27. The moon landing was faked because the flag was waving in the video. This is one of the most famous conspiracy theories in history. People claim the Apollo moon landings were faked in a Hollywood studio because the American flag planted by the astronauts appeared to be waving in the wind, and since there is no air on the moon, there should be no wind. Therefore the footage must have been filmed on Earth. Checkmate, NASA. Except this claim is based on a complete misunderstanding of what is happening in the footage. The flag was not waving because of wind. It was waving because the astronauts moved it. When astronaut Buzz Aldrin planted the flag, he twisted the pole to drive it into the lunar soil. This twisting motion caused the flag to move, and because there is no air on the moon, there is no air resistance to damp the motion. The flag kept moving for a while, slowly settling down. The flag itself was specially designed for the moon landing. It had a horizontal rod sewn into the top edge to keep the flag extended, because without air, a normal flag would just hang limp. The flag appears to ripple, because the fabric was wrinkled from being folded up during the journey. The wrinkles made it look like it was waving even when it was still. This has been explained thousands of times by scientists, engineers, and even mythbusters. But the conspiracy theory persists. Why? Because people want to believe it. Some people distrust the government. Some people find the idea of a grand conspiracy more exciting than the truth. Some people just enjoy being contrarian. But the moon landing was real. We have physical evidence. Moon rocks brought back by the astronauts have been studied by scientists all over the world. Retroreflectors placed on the moon by the Apollo missions are still used today to measure the distance to the moon with lasers, and lunar orbiters have photographed the landing sites, showing the abandoned lunar modules, footprints, and tire tracks. The flag-waving myth is based on ignorance of physics, and it disrespects the hundreds of thousands of people who worked on the Apollo program, the astronauts who risked their lives, and the achievement of landing on another world. And this leads us to another moon myth that is almost as persistent. Lie number 28. The moon is small and insignificant compared to Earth. The moon has a diameter of about 2,159 miles. Earth has a diameter of about 7,918 miles. So the moon is about 1/4 the size of Earth. In terms of mass, the moon is about 1/81st the mass of Earth. So yes, the moon is smaller, but calling it insignificant is absurd. The moon is unusually large for a moon. Most moons in the solar system are tiny compared to their parent planets. Jupiter has 79 known moons, but most of them are just a few miles across. Even Jupiter's largest moon, Ganymede, is only about 2% of Jupiter's mass. Saturn's largest moon, Titan, is only about 0.02% of Saturn's mass. Earth's moon, by comparison, is 1.23% of Earth's mass. That is huge. In fact, the Earth-Moon system is sometimes called a double planet because the moon is so large relative to Earth. The centre of mass of the Earth-Moon system, called the barycenter, is not at the centre of Earth. It is about 1,000 miles below Earth's surface. This means Earth and the moon orbit a common point, rather than the moon simply orbiting Earth. And the moon's size has profound effects on Earth. The moon's gravity causes tides in Earth's oceans. These tides have shaped life on Earth. Tidal pools were likely crucial environments for the evolution of early life. Tides also slow Earth's rotation. Billions of years ago, Earth's day was much shorter, perhaps only 6 hours long. The moon's tidal drag has been gradually slowing Earth's rotation. Billions of years from now, Earth will become tidally locked to the moon, always showing the same face to the moon, just as the moon is tidally locked to Earth. The moon also stabilizes Earth's axial tilt. Without the moon, Earth's axis would wobble chaotically over millions of years, causing wild swings in climate. Some scientists believe this stability was crucial for the development of complex life. The moon is not insignificant. It is one of the most important objects in the solar system, at least from our perspective. Without the moon, Earth would be a very different place. Life as we know it might not exist. And now let us talk about another myth that confuses people about the seasons. Lie number 29. The moon causes weather and natural disasters. For centuries, people have believed the moon influences the weather. A full moon brings storms, a new moon brings calm. And eclipses, well, those were always bad omens. Even today, some people believe the full moon makes people act strangely. The word lunatic comes from lunar, Latin for moon, because people once believed the moon caused madness. But does the moon actually affect weather? No. There is no scientific evidence that the moon influences weather patterns. The moon does cause tides, yes, but tidal forces are much too weak to affect the atmosphere in any meaningful way. Hurricanes, tornadoes, thunderstorms, droughts, none of these are influenced by the phase of the moon. Weather is driven by solar energy, the rotation of Earth, the distribution of continents and oceans, and atmospheric chemistry. The moon plays no role. What about natural disasters? Do earthquakes and volcanic eruptions happen more often during a full moon? No. Studies have looked for correlations between lunar phases and seismic activity. They found nothing. Earthquakes happen randomly, driven by tectonic forces deep underground, not by the moon's gravity. Volcanic eruptions are even less related to the moon. They're caused by the buildup of magma pressure beneath the surface. The moon's gravity is far too weak to trigger an eruption. But the myth persists because of a psychological phenomenon called confirmation bias. If you believe the moon affects the weather, you will notice when storms happen during a full moon and ignore the times when they do not. Your brain filters the data to confirm what you already believe. The moon does not cause weather. It does not cause disasters. It does not make people act crazy. The moon just sits there, quietly reflecting sunlight, causing tides, and reminding us that even the most romantic myths can be completely wrong. And speaking of reflecting, here is a myth about light in space that most people get wrong. Lie number 30. Space is completely dark. When you imagine space, you probably picture darkness. A black void dotted with tiny points of starlight. This is how space is always depicted in movies and photos. Deep, dark, empty. But here is the truth. Space is not dark when you are actually in it. From Earth, we see space as dark because we are looking out from the bright surface of a planet. The atmosphere scatters sunlight, making the sky blue during the day and hiding the stars. At night, we can see the stars because the sun is on the other side of the planet. But if you were floating in space, away from Earth, near the sun, you would be surrounded by blinding light. The sun is incredibly bright. Brighter than anything you have ever seen. Astronauts in orbit report that the sun is painfully intense. They have to wear special visors to protect their eyes. The sunlit side of the International Space Station is bathed in brilliant white light. The shadowed side is dark, yes, but that is only because the station itself is blocking the sunlight. Space is not dark. It is full of light, at least where there are stars, and there are stars everywhere. Hundreds of billions in our galaxy alone, trillions of galaxies beyond that. If you could somehow see in all directions at once, you would see starlight coming from every angle, faint but omnipresent. The darkness we associate with space is really just the emptiness between the light sources. Space is dark the way a field at night is dark. There is nothing nearby to reflect the light. But the light is still there, travelling through space at 186,000 miles per second, waiting to hit something and become visible. And in some parts of space there is no darkness at all. Nebulae, vast clouds of gas and dust, glow with light from nearby stars. Some are bright enough to be seen with the naked eye from Earth. The Orion Nebula, for example, is a glowing cloud of star-forming gas visible in the Sword of the Orion constellation. From inside a nebula, the sky would be filled with glowing gas, reds and blues and greens, lit up by the newborn stars forming within. Space is not dark. It is full of light, colour and wonder. We just happen to live in a relatively dim corner of it, and that brings us to the next myth, about the ultimate fate of the universe. Lie number 31. Black holes suck everything in like cosmic vacuum cleaners. Black holes have become the ultimate symbol of cosmic terror. Massive objects so dense that nothing, not even light, can escape. They are often described as cosmic vacuum cleaners, sucking in everything around them, devouring stars, planets, and space itself. The truth is far more nuanced. A black hole has gravity, just like any other object. The strength of that gravity depends on the black hole's mass. If you replace the Sun with a black hole of the same mass, Earth's orbit would not change at all. We would not be sucked in. We would just keep orbiting, exactly as we do now. The only difference is we would be cold and dark because there would be no sunlight. Black holes only suck in objects that get too close, past a boundary called the event horizon. The event horizon is the point of no return. If you cross it, you cannot escape. But as long as you stay outside the event horizon, you can orbit a black hole safely, just like you can orbit a star. And black holes do not actively pull objects toward them any more than a star would. The danger comes from tidal forces, If you fell toward a black hole, the gravity at your feet would be much stronger than the gravity at your head. This difference would stretch you into a long, thin strand in a process gruesomely called spaghettification. But this only happens very close to the black hole. Far away, black holes are not dangerous. They are just very dense objects with strong gravity. In fact, there is probably a supermassive black hole at the center of our galaxy, Sagittarius A star, with a mass of about 4 million suns. It has been there for billions of years, and it has not sucked in the galaxy. The galaxy orbits around it, so black holes are not cosmic vacuum cleaners. They are gravitational objects like any other, just taken to an extreme. And now, let us end with the two biggest lies of all. Lie number 32. We know what most of the universe is made of. This is the lie we tell ourselves to feel comfortable. We have mapped the solar system. We understand gravity, light, matter, energy. We have the periodic table of elements. We know how atoms work. We know how stars burn. We understand the universe. Right. Wrong. We do not know what 95% of the universe is made of. About 27% of the universe is dark matter, a substance we have never directly detected. We only know it exists because its gravity affects galaxies and clusters of galaxies. Stars at the edges of galaxies orbit faster than they should based on the visible matter. Something invisible is adding mass, holding the galaxies together. We call it dark matter, but we do not know what it is, not a clue. About 68% of the universe is dark energy, a mysterious force causing the expansion of the universe to accelerate. Galaxies are not just moving apart, they are moving apart faster and faster. This should not happen. Gravity should slow the expansion. But something is pushing the universe apart, and we have no idea what it is. That means we only understand about 5% of the universe. The rest is a mystery, and that leads us to the final, most unsettling lie. Lie number 33. The solar system is our permanent home. Humans have lived on Earth for hundreds of thousands of years. We evolved here. Our bodies are adapted to this exact environment. Earth's gravity, Earth's atmosphere, Earth's climate. It feels permanent. But the solar system will not be our home forever. In 5 billion years, the sun will expand into a red giant, likely destroying Earth. But long before that, Earth will become uninhabitable. In about 1 billion years, the sun will brighten enough that Earth's oceans will evaporate. Life, at least complex life, will end. If humanity wants to survive, we will need to leave. Not just Earth, not just the solar system. Eventually, we will need to leave the galaxy, because the universe itself is dying. Stars are forming more slowly now than they did billions of years ago. Eventually, star formation will stop. The universe will grow darker. Existing stars will burn out. Black holes will evaporate over unimaginable timescales through Hawking radiation. In the end, the universe will be cold, dark, and empty. This is called heat death. The solar system is not our permanent home. It is a cradle, a place where intelligence emerged, looked up at the stars and asked, what comes next? Every lie we have covered today, from the asteroid belt to black holes, stems from the same source, our need to simplify, to understand, to feel in control. But the universe does not care about our comfort. It is vast, chaotic, and indifferent. The truth is often stranger, more beautiful, and more terrifying than the lies we tell ourselves. And that is why we keep looking up, not to confirm what we think we know, but to discover what we never imagined. The solar system is not what you were taught, but what it actually is, well, that is even more incredible.